Good morning, everybody. Thank you all for joining for this webinar about imagery in ArcGIS. We may have a few more people come in, but I can get started with some of the housekeeping. So this is a webinar about imagery in ArcGIS with the focus on the S3 imagery that is made available by LINZ in AWS. We'll talk more about that, but if there's any questions during this webinar, feel free to ask them using the QA panel. So that should be showing up in your Teams window. You can ask any questions. I'll try to get to them at the end of the webinar if we have time. Otherwise, we'll reach out to you with answers to that question or more clarification. So what we would like to talk about today is first a quick introduction for imagery in ArcGIS, but then very quickly jump in to the New Zealand imagery and elevation data and how we can access that imagery, how we can manage that imagery, and how we can use that imagery. And like I said, at the end, we will do a Q&A. So if there's any questions, just drop them in. So with imagery in ArcGIS, we usually split it out that there's a couple of capabilities. So the first is management, allowing you to manage all your data just to make it more easily accessible by people. We can then do analysis on it to create insights. And there's a lot of visualization tools as well, and that can improve our understanding of the data. And another part is the reality mapping, and that allows us to create those imagery products like DEMs, true orthos, but also 3D meshes from aerial imagery or drone imagery. And then content is an integral part as well, and that is the content that you create yourself, that you get from third parties, whether that's public data, like we're going to talk about today, or private data, and being able to manage that and make it available as ready-to-use content within your organization or wider. And there's a trend that we're seeing where more and more of the imagery data is moving to the cloud. So a great example is that LINZ has started to push all of the New Zealand imagery and elevation data that's captured by councils to the cloud in a LINZ AWS S3 object store. But we also see Microsoft Planetary Computer, which is a large imagery collection of a lot of satellite data and other data types that can all be accessed through the cloud. And also in ArcGIS, we've got something like a cloud store where we can store the results for our analysis, or we can connect to as well. And then there's cache layer. So if we create a base map, we can actually store that in object stores as well. So like Azure Blob Storage or Amazon S3 instead of on a spinning disk. And the reason why we want to manage all that imagery is to make it more easily accessible by people in our organization. And that can be for to do exploration, to do analysis, maybe deep learning on it. And you can think about things like being able to do pixel classification or do object detection, change detection, trend analysis, or even post-event analysis. So there's a lot of use cases where this imagery can be used for once it's easily accessible. And today I want to talk about about the imagery that is hosted in the cloud. And as an example, I'll use the LINZ imagery that's in a public bucket, but this also works for other data that you have sitting in your own private clouds, for example. So there should be something to take away from, even if you're not using the LINZ imagery. But first I want to talk about what is available from LINZ. So for the New Zealand aerial imagery, it's mainly aerial imagery. There's some satellite imagery in there, but there's 595 imagery datasets currently available. And most of that imagery comes from councils. There's some from NIWA and LINZ, and maybe some others as well. And all of the data is publicly available. And it's licensed as CC BY, so you need to credit the source, but then you can use it whichever way you like. And all of the current and new imagery is being loaded into that AWS S3 bucket. But there's also a lot of historic imagery, and it can be scanned imagery as well. So here we see an example of a data set that's in there from Auckland from 1939 to 1940 that we'll have a look at later as well. So there's a source of information in that bucket. Another data set type is the elevation. We almost got full coverage of New Zealand now, which is great, which was so different 2 years ago. But there's 195 elevation data sets, again, mainly captured by councils and made available, but also NIWA, LINZ, and others have contributed to that. It's all publicly available, again, and these data sets consist usually, almost in all cases, of a DEM and a DSM with a 1 meter resolution. And it's derived from the LiDAR that's been captured over New Zealand. And what LINZ has done as well is create a folder where for both the DEM and the DSM, where there's basically a mosaic showing all of the latest data. So if there was overlap, they just show the latest, and you can get it all from one folder that I'll show later as well, making it easy just to find the latest elevation data if you need that. Another project that has kicked off is the 3D coastal mapping. And the aim is to map 40% of the New Zealand coastline from 200 meters land inwards to about 25 meter depth using various capture ways of capture. A lot of information about it is on LINZ's website, so yeah, please do check it out. They also got a progress tracking map, so you can see what areas are going to be captured, have been captured, and are available already. But that data also goes into the S3 bucket. At the moment, there's 16 data sets, and that includes some derived data sets. I think it's 4 main data sets that have currently been added, and some are DEM and or DSM data sets. And again, LINZ also creates a aggregated folder with all of the data in one place, so you don't have to download different folders if you need that data. Then I want to talk a little bit about all of those data sets. And what it does, it uses the STAC metadata format. And STAC stands for Spatial Temporal Asset Catalog. And it's become more and more a common language to describe geospatial information, especially raster data. All of the data that is available is tiled, so you don't get one big TIFF for a data set, but it's all tiled into smaller areas. Like I said, it's hosted in AWS S3 in public buckets, so everybody can access it. And TIFFs themselves are cloud optimized, and there's more information, technical information that you can find. And I'll show it later, but LINZ has got GitHub pages for all of the different data sets with more of that information. All right, so that now it's sitting in the cloud. How can we actually explore the data? How can we find it? How can we download it? How can we use it? And there's a couple of ways. And I want to go through each of these. So there's a website, Radiant Earth, that we'll look at first. That's basically just a web browser explorer. You can use the AWS command line interface if you want to explore or download the data locally. But also in ArcGIS, you can connect to it using a STAC connection. So that is using that STAC metadata format. But also through a cloud connection by just directly connecting to that cloud storage. What we've done as well is trying to make it easier to download the data. So we built an elevation download app, which currently downloads the elevation data. And we're looking at seeing if we want to make that available for imagery as well. So let's just quickly show some of these in action. And I've created a few demos that I'll talk over to show you more about it. So for me, the Radiant Earth website, which is a not-for-profit organization that built this, allows us to connect to the different catalogs for NZ Imagery, the NZ Elevation, and the NZ Coastal datasets. And basically what it does, it reads all of those STAC JSONs and creates a list of the data that's available. And it allows for some easy filters, basically just a search. So we can search for Nelson here. We can see what data sets are available. When we click on it, we can see the extent, and we can show the actual captured area on the map, because that's in a GeoJSON that's available. We can see metadata, and here you can see all of the tiles. So if you go into the tiles, all these tiles have their own metadata as well. There we can see. We can share a link to this if we want to share this information with someone. And then here the elevation, that's basically the same. But what I want to show here is if we search for New Zealand, it shows up those derived data sets. So there's a few hill shades, but also the DEM and the DSM all show the latest data available. And using the viewer here, we can see what data sets are being used to create that mosaic layer. And it has metadata. So an important one here is the last updated one. So if new data is being added to this data set, that will be updated as well. And then we've got the entered coastal, and also here you've got a New Zealand folder with the DEMs that combines all of the captures into one location. So here we can see the area that's captured here in the north, get all the metadata. Again, these are tiles, so there's just a little bit of data in this tile, but you download a full tile with just the data where it's available. So this is usually one way that I have a look to see what data is available. But there's another way as well, and it's especially useful if you need to download the data. And that's using the AWS CLI, and that stands for Command Line Interface. So it's a little app that you have to install, and you can get that from the Amazon website. So in here, you can find the right installer, you download it, you install it, and then there are some configuration settings that you have to go through, but that's all documented here. Once you have it set up, you can use what is PowerShell or the command tool in ArcGIS to, for example, list the data. So here I'll list data from S3. So that's AWS S3 LS, stands for list. And then we can connect to that bucket again. So here we're connecting to the elevation data set. We click on it, and we can see that all the data is organized into the different regions, and New Zealand being one of them. We can then, I don't know, look into the Canterbury folder and see all of the data sets that are available there. And we can then look into one of these collections. And what we see here is those DEMs and DSMs again. So this is where you can choose to download both, or just a DEM or just a DSM folder. And if we look in that folder, then we can see those same tiles that we saw before. So they're relatively small TIFFs, all accompanied by a JSON with the metadata around it. In many cases, there's a capture area GeoJSON showing the actually captured area, and the collection JSON, and that has the metadata for the whole data set. What we can do from here as well is not just list it, but we can also copy it. So using the AWS S3 CP command, we use recursive to download all the files in that folder. And then we point it to the location that we want to get the data from. So in this case, it is at Christchurch, the EM data, and we give it a destination location. So in this case, it's a folder on my computer. We hit enter, and it will start downloading all the data. Quite quick as well, depending on your internet connection. And once it's on your computer, you can basically just use it like any other raster data set on your computer and manage it like you would other data sets as well. So that's one way of downloading it. And because it can be a little bit tricky, what we thought is we create an app, at least for the elevation data for now, to download the latest elevation data to make it a little bit easier to get the data on your computer. I'll show other ways of being able to directly connect to the data as well without downloading it, but sometimes you just want to have the data locally. So what we've done here is we build an experience builder application, and that's actually being updated by ArcGIS data pipelines. So that runs every day. So it should have the latest data available. And some things that we download are the extents. So for the DM and the DSM, they're almost the same, except for 1 or 2 data sets. But you can see with the coastal data, there's a few less coverage areas. So here we can see the tiles that the data is made available of, and we can click on one, and then we can see whether there's DM, DSM data available, or the 8-meter DM, which is a national data set hosted by LINZ. If there's no data available, you won't be able to download it, but you can still download the 8-meter DM because that is national coverage. If there's coastal data available, then as you would expect, it shows up as a download link here as well. Some of these tiles are actually made up of multiple data sets. So when you click on a tile in this app, you can see what data sets it's being made up of. So in this case, there's 4 different data sets that you get data from when you download this tile to your computer. So this is another way to quickly get some of the imagery data on your computer. But then I want to start talking a little bit about how we can connect to the data directly. And the first one I want to cover off is the stack support in ArcGIS Pro. So like I said, stack stands for Spatial Temporal Asset Catalog, and a standard in providing a common structure using JSON files to expose all of the metadata for imagery datasets. And what is good to know is that there is a static stack and a stack API. And we'll see the difference in ArcGIS in a minute. But with the stack API, you can actually filter and search based on attributes and extents to find specific data sets. A static stack is basically just a bunch of JSON files without an API, and it allows you to list the data like we saw on the website, but it doesn't allow you to search to see what data is available for a certain extent, for example. So at the moment, LINZ just has a static stack. Hopefully they will create a API at some point as well. But I do want to show how it works when you've got a stack API, because there's other catalogs as well that can be important in your work to get data from. And one of them is the Microsoft Planetary Computer. And that holds a large collection of data that can be used in ArcGIS and can be found through the stack support in ArcGIS. So I just want to show that. So here in ArcGIS, we have a stack connection that we can create using the Insert tab. Once we've created this one, and I've done it for the Microsoft Planetary Computer already, we can start exploring what is in there. So there's a lot of data sets in there. So if we can search for Landsat, so we can see all the Landsat data in there. We've got the Sentinel data. And if we hit the properties of one of these data sets, we can also select what bands we're interested in. So for this example, I'm mainly interested in the RGB and the near infrared. So I've selected those. And what we can do then is we can set some search attributes. So we can specify a date and time from when the data was captured. We can set an extent for map extent, for example, or a layer that we have in our map. And for New Zealand, quite often cloud cover is a big issue. So we can find those images that have less than a percentage of cloud cover, 20% in this case. It shows us all the results. And from here, we can select one or multiple. If we have a mosaic data set already, we can add it to that mosaic data set, or we can create it as a mosaic layer to our map if we select multiple. In this case, I've just added one data set. So here you can see the RGB visualization, but because we also brought in that near infrared, we can also show it as color infrared, which highlights the vegetation. Quite nicely. So this is how it works if you've got a stack API. Now let's go back to the New Zealand data. So here I've got a New Zealand elevation stack. Let me add the new one just to show you how you can add it. And I'll add the New Zealand imagery in this case. And the connection, you just need that URL to that catalog.json. The easiest way to find it, I found, is just to go find the GitHub page for the coastal elevation or the elevation data or the imagery data. And on here, you can also quickly go to that stack browser that I showed before to find all the data sets. But what we're actually interested in is that URL that we see here. So that is the URL to the catalog.json. We can copy that link and then go back to ArcGIS Pro. Where is it? Yeah, and we paste it in. What it does then, it just connects to the catalog.json and it will just read all of the collections that are in there. So we can start exploring this. What you will see, the main difference is we don't have those search parameters. So we can't search by attribute or extent because it's basically just listing all of the JSON files. Still, we can explore the data. We can see all the tiles that are in there. And we can select one and then add it to the map. Just don't know what area we're actually adding, but I'll show another way how we can actually manage the data as well. The main thing is that once we add it to the map, we're not downloading it. So we're just connected to that storage in the cloud. And we just got an imagery data set like any other imagery data set in our map. So this is one way. Especially useful if you're using something that has a stack API, like the Microsoft Planetary Computer. All right, the next one is using a cloud store connection in ArcGIS Pro. So in ArcGIS Pro, we can connect to a lot of service providers, including Azure, Amazon, and Google, and basically use the data as if it's in our catalog. The thing is, the data is read-only, but we can use ArcGIS Pro to manage it. For example, using Mosaic datasets that I'll show a little bit later. I just want to show how we can connect to these datasets that are hosted in the cloud. So again, here I've got one added already, and this gives us those same regions that we saw before. We can go into the datasets. Here we can see that DEM and DSM as well. And we can see all of the TIFFs and their JSONs. We can't really do much with the JSONs, but the TIFF we can just add to our map. And again, it will work as a normal raster dataset, as if it's local. So we can do things like change the stretch type, or turn on the DRA, the dynamic range adjustment, change the symbology. So that's pretty cool. Now let me show you how we can add a cloud store, and there's a few ways. There's always a few ways that you can do things in ArcGIS Pro. If you have a cloud store connection already, like this New Zealand elevation, you can just right-click on the cloud stores and create a new cloud storage connection from here. The other way is through the Insert tab on Connections. You can find the stack connection, but also the cloud store connection. And create a new connection here. And the last one is using the geoprocessing tool. So that also allows you to automate it if you need to. All right, let me just create a connection here through the Connections tab. And what we do is we give it a name that it will show up as. We select one of the service providers. So you need to know where the data is sitting. So we know it's in Amazon S3. So we will add that. And then if it's private, you need access keys and secret access keys. If it's a public bucket, we can do something else, but we don't need an access key or secret access key in this case. We do need to know that bucket name that you can find on the GitHub as well. So it's NZ Imagery, NZ Elevation, or NZ Coastal with a dash after NZ. And you can actually specify a specific folder, one of those region folders. So if you're not interested in other areas, you just type in Nelson, for example. Another region is where the data is actually hosted. where the data is actually hosted. So in this case, that's in Sydney. And because we're using public access, we have to tell it that we do not need to sign in. So we set that to yes. If you've got credentials stored on your computer or you've got them, you can add them in here and it will connect to it. But if you don't have any AWS credentials, that's what you do to connect to the data. And again, we see the same regions and we can just browse through it as if it's a catalog. And here you can see as well that it's got a lot of historic data that's been given by the councils to LINZ, and a lot of them are scanned maps as well. It's really cool. We'll see an example of that later for Auckland. You can add them to your favorites. Done it a few times now, preparing for this, but that makes it easy to find. The other thing what I usually do is add them to a new project, so it always shows up when you open a new project in ArcGIS Pro. So that's just a quick tip. So you don't have to create those connections every time that you create a new ArcGIS Pro project. All right, now that we can connect to the imagery, we still see that we've got all of those different tiles. So it would be very useful to have just a one item endpoint to the data set. And what we can use for that is a mosaic data set. So it's a very powerful data model, and it basically catalogs, it references all of those tiled imagery data sets into a mosaic data set, and it'll give you that one endpoint that you can add to your map. You can set certain parameters on the mosaic data set as well, but it is also the source for if you want to create a base map, for example, a tiled cache, or if you want to publish it as an image surface to make it wider accessible in your organization, for example, to allow people to do analysis on it. But that's just for one mosaic data set. You sometimes need to manage multiple. For example, our imagery base map, what we do is we actually manage all of those different data sets. So our imagery base map is made up of around 150 data sets, and they all have different areas, different years, different resolutions. And what we do is we create a mosaic data set for each of those data sets. So that's something you can do as well. And on those, we add the metadata. So we can put in the acquisition date, the source, and so on. We also build overviews for a smaller scale resolution and create footprints. And we usually use that capture area GeoJSON to create our footprints. That main we can then add them all to a main mosaic data set if we want. And then we can use the metadata to order the imagery. So we can define what is being shown on top. And mosaic dataset also allows for dynamic mosaicing, but if we have certain rules on what imagery we want to show on top, we can use the acquisition date, for example, and a resolution to create a Z order. And once we've done that, we can again create a tiled cache map, or we can publish it as an image surface. Creating a mosaic dataset is pretty easy. So we can just go to the file geodatabase, create a new mosaic dataset, or use the geoprocessing tool that it opens from here. We give it a name. So let's just add the New Zealand DEM data. We can give it a coordinate system. So you can use Web Mercator because it will transform on the fly. Then in this case, we use the New Zealand transfers Mercator, and we can give it a vertical datum as well. So for New Zealand, this data is all in the NZVD 2016. That's all we need. We create it, and what it will do is it will create basically an empty bucket, an empty catalog, nothing in there yet. And what we can do next is we can actually start adding rasters to it. So using the add raster tool, we can add a file or a folder. So in this case, I just want to add all of the DEM for New Zealand. We grab the folder and we can navigate to it or just use drag and drop. And we can then start creating the mosaic data set. And what is good to know is that it references all the data. So it references the data that's sitting in the cloud. It doesn't download the data. And this takes about a minute or so. So what I've done for this presentation is just sped it up a little bit. We don't have to wait for it. And I'll show you how long it takes, how long it took to get all of this data in. So in the details, we can see that it took 1 minute and 22 seconds. And we can see the footprints for all of the different tiles that have been created. And we can now start zooming in to any location, and it will stream in the data straight from the cloud. At the moment, it doesn't have any statistics calculated yet, but we can use the dynamic range adjustment to make it a little bit more visually appealing. But again, this is just another data set where we can use all of these standard tools in ArcGIS, for example, to change the visualization of it as well. But another step that we can take is we can update the metadata for this mosaic data set, which is quite useful if you use it in your organization and you want to know the acquisition date, for example, or the source of it. And there's a few fields in there already, but you can add your own fields. So you can add fields for the acquisition date or for the organization you need to credit for the data, and store that all in the mosaic data set with the data. So that's a quick way that you can start to use the data in ArcGIS Pro, because now you just got a data set that you can use like any other raster data set. You can also build overviews on top of it if you want to have some faster performance for the smaller scales. Those will be created locally. But another thing you can do is you can use raster functions, and you can publish this mosaic data set as a service. So a raster function is basically an on-the-fly analysis or visualization on your data. So you can, for example, think about showing the elevation as contour lines. And you can create raster function templates where you can chain raster functions together. And I'll show one small example of that, but you can create pretty advanced analysis templates through that method. And like I said, it's on the fly, so it doesn't create intermediate outputs or final outputs. You can create an output at the end, but all of these raster functions, they perform on the fly, so that's pretty useful. Those raster functions you can also add to a mosaic dataset, and it basically means that if someone adds a mosaic dataset, they have access to all of those raster functions as well. And when you then publish the mosaic dataset as an image service, those raster functions can be added as well, so you can use them in the browser. All right, so let me just show you how that works with the raster functions. So here we have that same DEM, and like I said, it is just a raster, so we can do things like using the dynamic range adjustments, so that uses the min and max values in your extent to stretch the data. And here we can see how good you can see all those streams in the landscape. We can also change the color schema. So there's a few elevation color schemas that you can use in here. But an interesting one as well is to use the raster functions. So there's a whole load of raster functions, and one of them is the contour. So we can use the DEM as an input. We can set the contour interval, for example, 1 meter, and we create a new layer. Like I said, this is done on the fly, so it will calculate all of these contours on the fly, so we don't need to export it as a separate output. What we can do as well with these raster functions is we can save them. So instead of creating a new layer, we can save them. And we can then add them to a Mosaic dataset. So on a Mosaic dataset, we can manage processing templates. And here I've added the two contours, 0.5 meter and 5 meters, and a color ramp. And once you've saved them, you can just use the import button to add them to your Mosaic dataset. So in ArcGIS Pro, they just show up here in the processing templates, but we can also start to publish it. Good thing to know is if you publish a Mosaic dataset is you publish it from the catalog. So you right click on the Mosaic dataset and then share it as a web layer. In this case, I'm connected to my ArcGIS Enterprise that has an image server installed, so I can actually publish this, this layer. Just reference the data. I only got one server on this enterprise. We can set some properties for the image surface, so whether we want to allow analysis or copy or download, and then we publish it. And once it's published, and here I've added that layer and a few other, here I've added that layer to the DEM, and we can see those processing templates in the map viewer as well. So we can quickly select them, and we can see all of these raster functions being used in the map viewer. We can also use the map viewer to change some of the visualization. So in this case, I created some classes, and I used 0.5 meter steps from 0 to 2.5 meter, and that can highlight areas at risk for sea level rise, for example. What you can do with both the processing templates or when you change the symbology or the pop-ups is you can save that with the layer, or you can save a new layer. And that new layer will reference the same surface, but it will use the symbology and if you change the pop-up configuration with that layer. So now that I've saved it, it will show up in my content, and I can just add it to the map. I probably should have turned off the other ones so it's more clear. But if we turn the other ones off, you can see that it has the same symbology as the layer that I used to save it. So that's a way of using raster functions. Now I just want to change gears a little bit and step away from ArcGIS Pro and go to ArcGIS Enterprise. So we used, just before we use ArcGIS Pro to publish to ArcGIS Enterprise, but now I would like to show how we can actually publish a hosted imagery layer in ArcGIS Enterprise using that cloud stored imagery. And for that, we do need to create a data store first, and it can be user managed, and from 11.5, the latest version, it supports anonymous access. So that is cool. Before you needed authentication, or you can do it through the server manager, but that one still requires authentication. So you need, in this case, an AWS key. We then create a hosted imagery layer using the imagery collection because we just want to reference the data. We don't want to download the data. So let me just show you how we can do that in ArcGIS Enterprise. So in the content, we can add a new item. In this case, the data store. And we can create data storage of the type folder, database, and in this case, we choose the cloud storage. We can choose different providers. In this case, Amazon. It actually picked up the key that I used as well, but we don't need to use that. So we can choose anonymous here because it's a public bucket. We do need to specify the region that the bucket is in. So that's Sydney, and then use the bucket name. So in this case, we're adding the imagery. We select the server that we want to connect this to. So if you have multiple, you can select multiple servers here. I just got the one that has an image server on it as well. And we give it a title, and I've already got an imagery, so I'll just call this one Imagery Webinar. That creates a connection, and it basically creates an item with the information about the data store. We can also share this as an item if we want to make it available in our organization for other people to be able to use it. So we can create a new imagery layer here as well. We don't need ArcGIS Pro for that. And I choose the image collection because I want to reference the data, but you can download another data set as well, and it will just persist the data on your machine. We can use local data or upload data or use the data from the data store. And here we see some different data stores that I've configured. So the imagery and the new imagery webinar. We can open that and it will list all of the information, all of the data sets that are in here. And we can just browse. Let's go to the first one, Auckland, and we can see all of the data sets available. So from here, we can select one or multiple data sets, go next, fill out the details. In this case, it's the Auckland 1940 imagery. And then we can create a layer. And this takes a few minutes because what it does, it in the backend, it creates a mosaic data set, references all the data, makes sure that the metadata is all in there. And that takes a few minutes, but once it's done, you've got that a new item in your organization. You can do some image management as well. So in case you want to update the footprints or the overviews, you can do that in here as well. And then you can add it to the map. So here we can see that 1940 imagery, and we can start to look at all the different changes or the things that actually haven't changed in all those years. Like this building seems to be very similar to what it was. Other areas, however, have been massively changed over the years. Here we can see Spaghetti Junction and all of the houses that were there. We can put the hybrid layer over it and see where all of the infrastructure is that is currently in Auckland. So this is how we can very quickly go from that cloud-hosted imagery to a useful layer in our ArcGIS Enterprise, where we don't even have to touch any other software. All right, so another example I want to show is using raster functions in the map viewer. So in the same way that I created the other layers, I also created a DEM and a DSM where we can see the elevation. So in here, we can see the elevation of the DEM, 235. So that's the ground level. And then for this tree, it's 249. So if we want to see the height of a building or a tree, we got to subtract those. We can do that in our head. It's not too hard. We can grab a calculator. But we can also use raster functions to have it calculated automatically. So everywhere that you click in the map, you will get the actual height of the object in the map. And for that, I built a raster function template in the map viewer. And basically what I do is use the DEM and the DSM and a very simple expression where we subtract the DEM from the DSM. So that is, so then we can get the elevation of the actual objects that are on the surface. We can then use them as a processing template. So I've got them here. And then what we can see is if we click on this tree, we just get the height of this tree instead of the actual elevation of the tree. So now we know that it's around 13 meters. These are the values that were used to come to that number. So without having to create an extra data set, we can now go anywhere in the map, click on the map, and get the height of a rooftop, for example, which is close to 5 meters. And the ground we will see is close to 0 meters because that is what it's using as a base. So that's a real easy way to get those elevations. But you can make this more intelligent as well. You can bring in other data sets and do more analysis on it. All right, so another example I would like to show is when we have published our mosaic dataset as an image service, like we saw before, but in this case, an image service that used all of those source mosaic datasets into a main mosaic dataset. What I did is I added all of the imagery datasets into one main mosaic dataset. And using the Imagery Viewer Instant app, we can now start to explore that imagery. So here Zooming into Wellington, and again, using the Imagery Viewer Instant app, we have a widget where we can find all the imagery that is available for this location. So it loaded one by default, but let's go back in time a little bit more for the first layer. So the 1987 and 1988 imagery. So we can quickly find it, but we can also add a slider to this app. And in this case, I'll add the latest urban from 2021. And now using the slider, we can see all the changes that have happened over those few decades for this area. But we can go anywhere and find the data set that is available there. We can also use it for some analysis. So when did something get changed based on all the imagery that we have available? When were buildings being built? What activity was in a location in the past? So a great way to explore all of that imagery that is in the bucket. We actually see a trend of organizations starting to use this imagery. So not storing all of that imagery locally anymore, but making use of the cloud storage. And one of the ones that I want to bring to the attention, and they did an amazing presentation at the latest NZDUC as well. So I can't top that, but I'll do my best. So what they did is they created an imagery viewer using ArcGIS Experience Builder and a custom widget, both for the aerial imagery and for the elevation data. So what we see here is a landing page, and they've got a few apps that you can explore. And I want to focus on the aerial imagery collections app. So if we open this app, then we can see that as we pan around, it will update the list of available imagery for that location on the left. So if we zoom to an area, we can see all of the different data sets. We can select one, we can zoom to it as well, and we can see what this area looked like in 1939. And we can select any data set that is visible here. But what I did as well is added a compare, so a swipe. So we can also show the latest imagery for this area. And we can see some of the features that are here, that are still here, that existed in 1939 as well, including, but also some new features like the road and this canal. We can also see the massive development that has happened in this area as well. So this is a great way to find imagery for an area that you're interested in. And they've done something amazing with the elevation data as well. So here we see those contours that I showed before, and you can select the different contour intervals. But what they've done as well, because some people need it locally, is they created an app that allows you to download it for, 10,000 hectares. For 10,000 hectares, and once you find the area, you can hit the export contours, and it will download it as a file to your database, so you can use that later. Yeah, so that's pretty amazing, and I would love to see more examples. If you have any, please send them to me, because I think it's quite powerful that we now, as New Zealand, have access to all of that imagery that we can easily use for our exploration and our analysis. So with that, we've come to the end of it. I've covered a lot of information, and I want to point to some resources that are available as well. So we built a story map, and we're going to expand on that and update it as well with the latest coastal data, but also the new capabilities in ArcGIS Enterprise 11.5. But it has guides on how you can use that imagery in ArcGIS. And again, it's very similar to using any cloud stored imagery in ArcGIS. So even if you're not using the LINZ data, it might still be of value. Also, because we have now almost full coverage for the elevation data, I want to highlight the guide for using elevation data in ArcGIS as well. So it has some great tutorials on how you can use that, the raster functions, how you can create slope maps, but also a really cool one is how you can create REMs. So those are relative elevation models that you may have seen on LinkedIn, Instagram, great renders of especially river streams, especially around those braided rivers that we have in New Zealand. Yeah, so with that, I want to go through the Q&A if there are any questions. So we'll have to look at that myself, see if anything has come in. At the moment, I think nothing has come in as of now, so that's good. That hopefully means that everything was quite clear. I can wait for 30 seconds on this. I just want to let you guys know that if there's any questions on how to use this data, always feel free to reach out to us, to Eagle, to your account manager, to the content team, and we are happy to help. I think that Claire, I don't know if she put it in the chat for everyone to see, but links to those story maps as well. So what I did in the previous slide is put a link to the content hub. So if you type in content.eagle.co.nz, it will take you to the content hub, and there is a tab in there with how-to guides. And all of the how-to guides that you see here, but also others about deep learning, for example, can be found there. So if you want to learn more and have step-by-step guides on how to do something, please go and check that one out. Well, in that case, I want to thank you all for your attention. And oh yeah, one question: will a recording be available? Yes, and the recording will be available, so you can watch everything back and share it with other people in the organization or people who might be interested. And also feel free to share those links about the story maps and the content hub around. Well, thank you all for your attention, and I hope you have a great day, and hope to see you at another webinar hosted by Eagle. Thank you and bye.